Hi everybody, my name is Anibal Azevedo now. This is the class number 6 of the third track about how we can apply artificial intelligence on the context of container ports logistics. So now we're gonna continue the previously class. If you didn't see the previously class, it will appear a card somewhere. And now what we're gonna do, we're gonna use the code from previous class and make a better code. So I will also remember you that in the description of this video you can find all the code. You can find everything that we made in this class and previously classes. So it's interesting. If you want to learn, you can see the code, you can manipulate, you can change, you can test, you do your own tests. Okay, so let's see the code that we made in the Google Colab. So here is the this code, class code right here. We'll copy the previously class code. So what I gonna do, I gonna produce a more general function. What's not good here is that this function is very dependent of the number of rules of each stage. Would like to make this more general. So let's start to erase this. Okay, so I will not return this. So imagine that I have a number here, and I would like to return the number, the right number, or I just would like to return a list of numbers. Okay, so instead of return three variables, I can return a list of numbers, not three variables. It's more interesting to perform this. Okay, so what's the problem here? I don't know. Uh, So let's do it this. So I return this list of rules. So what's the problem here? I can have many more stages than three. I can have four stages or five stages, and in for each stage I can have a very different number of rules. So how I can use or how I can inform this aspect? I can use this number of rules for each stage or and 3, 6, and 4. Imagine that we have these numbers, okay? So in the first stage, I have 3 rules, or the second, I have 6 rules, and then the third stage, I have 4 rules. So I will produce the total number of rules by doing this. I have also to import another library, NumPy, that has this very useful command, uh, NumPy. The nickname will be NP, and the NP prod. Let's see what's this rule. Uh, this will do. I will comment this. Okay, at this moment we will not explore this. So let's understand what this command will do. So I'm not using this function. Okay, at this moment I will use in another manner, not this. I will change something here. It will be more compact and will be more general. Okay, so the total number of rules that we have here is 72. And we multiply 6 by 4, I have 40, 24 multiplied by 3, and we have 72. So what is the question here? How we can pass this information to this function? It's very simple. You can use this information and rules. And how we can use this information now to avoid this? Because if you have 3 stages, we have to we should have 3 variables. If we have imagine 10 stages, we should have 10 variables. Not good doing such thing like that. So I should use this. I should get the number of rules. So imagine that we have 3 stages. So this is the number of stages. In fact, um, and for each stage, I will make this 0. Yeah. Okay, so I will comment this. We're not gonna use at this moment this. Okay. So let's see if I made a call for this function, something like this. Imagine that we are in the number 1, and what happens? I will return the x value. So if I want to see something, I should put a variable here and print this variable. So we are just in the beginning of this function, okay? Then I believe this length. Oh no, 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 it's not right. The name here is not right. It's y, and it's not working. Okay, now it's working. So see, if this number of rules has 3 stages, this will also have 3 values. This the dimension of this list will be with 3 elements, 3 items. So what we should do for each element that we have here, we gonna use not 0 but another number that we're gonna start compute now. We're gonna use range and number of stages here, okay? And number of stages for each stage. For each stage, we're gonna use np prod. How many rules we have from the first stage until the previously stage? How we can get this? We should perform this. So we're gonna apply this operator np prod uh, to this range of elements. Okay, so let's print this and see better what it means. Okay, so in the first stage we have just one rule because we don't have previously stages. In the second stage we have 3 rules from the previously stage, and finally in the last stage we have from the previous stages 18 rules. So it's perfectly this is the right number that we apply here. Remember these equations that we have in the previously video, we have used it in the previously videos. So it will be the this part of the equation. This is the number that we're gonna employ. And finally, we have also the equation. How we can use the equation? We can use math floor. Let's use exactly this. But we're gonna use in a more uh, general way of doing this. Math floor divided by n, which is the number of rules employed, number of combination of rules employed until the previously stage. Okay. So what else? Here we're gonna use the number n rules for this particular stage. See that? The number of rules in this particular stage, the number of rules in this particular stage, the number of rules in this particular stage. Okay? Let's see if I'm forgetting something important or missing something important. I don't think that is wrong. So what is the last thing? We should store this information in the right stage of this list x, this variable list. So we're gonna store something like that, not 0 anymore, but this number. Okay, so we can erase this. Let's see if it's okay. I believe it's okay because why we are not using this -1 because we start your range from 0, not from 1. Okay? So we can use without this -1. So now what we have what we have here, we have math floor, okay? Number of rows 1 plus 1 here. I believe that's everything. It's it seems to be okay. Number of rules, okay, 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 okay. So this is the combination that we get if we apply the number 1. If we apply the number 0, let's see, we get 1, 1, 1. So what we should take care about, we should start with the number 0, right? Because if you want to if we start in the number 0, we start with the first combination of rules. How we can get this more general, or how we can verify if this is working? Let's see, using this 0 to n, the number of possible rules here. And finally, we're gonna print not only the result that we got, um, number, what is the number, +1, and what it means in terms of rules. If we use this number, how we can translate this number in terms of combination of rules. So number of, so here we have just 1, 1, 1, 1. It's not right. Okay, translate not 0 but this variable. Okay, now we can verify that if we use number 1, this will be the combination of rules. This unloading rule, this loading rule, and this quaquaring rule. So we can get all combinations of rules. But what is the interesting thing here? This code is not dependent. If we want to add more rules oh, I have one more stage with 5 rules. Okay, I will get all possible combination of rules immediately. This is totally get all possible combinations of stages with this all rules of each stage. See that? So it's very interesting because we can add more rules, add more stages very, very fast, just using a list to indicate this. Oh, I have more rules, I have more stages, and we get a fast translation, a fast table to translate this number into the corresponding rules that should be used for each stage or for each agent. Okay, so this is very interesting encoding. And before I proceed, I should define more interesting things. I should define more functions that will help us to produce the simulation, the encoding of the encoding, how you can employ this encoding into the port operation simulator. So I have to define more functions, and in the next video I will define more functions. I will help you to understand how you can use more functions to employ this encoding. Okay, so I hope you just find this video interesting and useful, and see you in the next video. Bye.